Okay, so we're on page 38 of the note spiral, and we're going to talk about a more complex blocking question. All right, this one is more complex. However, I think you'll find it interesting and somewhat enjoyable, actually. So, a new type of fish food has been available for salmon raised for fish on fish farms. Your task is to design an experiment to compare the weight gain. So this is what we're interested in. This is going to be our response variable raised over a 6-month period on the new and old types. So basically we have this treatment, new and old types of food. The salmon you'll use for this experiment have already been randomly placed in 8 large tanks. So they've already randomized the way they're placed in a room that has a considerable temperature gradient. Specifically, tanks on the north side of the room tend to be much colder than those on the south side. The arrangement of the tanks is shown in the diagram below. Describe a design for this experiment on weight gain that takes into account this temperature gradient. So basically, we have something already in place, and that is a temperature gradient, and we want to know how we're going to control for it. And since the temperature gradient already occurs, this means we're working with a blocking design because we're not assigning the temperature gradient to parts of the room. It already occurs, and since it already occurs, it's going to be something that we block. You always block on variables that exist that you think will have a great impact. Obviously, they think the temperature gradient will have a great impact, so we're going to need to block on this. I'm going to pause the recording. So, resuming the recording, they said the temperature gradient, and they said the north side of the room, and I'm going to assume that this is the north side of the room, this is the south side, and this is the east and the west. And we know that we are worried about temperature gradient, so I'm wondering what all impacts the temperature. Well, I have a heater, so that's one thing, so that's impacting the temperature. It looks like I have a window here, and it looks like I have a window there. So that's going to impact the temperature, and the door might impact the temperature also. Now, when we block, we want to block in such a way that each group has the similar amount of issues. So it's like, gosh, to do that, I'm going to want things to be equal distance from the heat sources, whether it's cold or heat that we're dealing with. So for me, I look at this and I go, well, you know what? 6 and 7 are equal distance from the heater, and they're equal distance from that window. This one's from this window, this one from that window. So they have close to the same distances from the window, and they appear to be about the same distance from the door. So I would say 6 and 7, this group right here would be a good block. So I would say 6 and 7 would make a good block. Well, by that same token, I can look at 2 and 3 and go, gosh, they're really close to the door. Both of them are about the same distance from the door. This one's close to this window. This one's close to that window. And they're a long way from the heater, but they're about the same distance from the heater. So I'm going to say 2 and 3 might make a good block as well. All right, so we've taken care of 2 and 3. Now things are starting to shape up where I can start to see where I might be going. Number 1 is close to this window. Number 4 is close to that window. So they're about the same distance from windows. They're about the same distance from the door. And they're about the same distance from the heater. So 1 and 4 appear to be a good block. And then lastly, we only have 2 left. And let's make sure they make sense. But our 2 left are 5 and 8. And 5 seems to be is this distance from the heater, and 8's that distance. So 5 and 8 are about the same distance from the heater. 8's pretty close this distance to the window, which happens to be the same from 5, and they're both equal distance from the door. So these would be my blocks. So ideally, I would break this down into 4 blocks. Blocks 6 and 7, 2 and 3, 1 and 4, and 5 and 8. 6 and 7 because they're close to the heater. 1 and 4. 2 and 3 because they're close to the door, 1 and 4 close to the windows, and 5 and 8 are farthest away from all sources of gain, heat gain and loss. that's the way I would break this down. Now we need to go further into the problem. So I first talk about the sources of heat and gain or loss, because that lets the reader know that I understand what's happening. The sources of heat gain or loss are the windows, the door, the heater, and the north/south sides of the room. I would block the tank so that each tank in the block would be equidistant from the source of heat gain or loss. So I'd block 1 and 4, 2 and 3, 5 and 8, 6 and 7. So I've explained my blocks. I just listed them nicely. And it's really important that you make a nice list of it so it's easy for someone to find. These blocks are the most homogeneous. I could have said similar blocks based in regards to heat gain or loss, because remember, we want to be similar when we block. We want all freshmen in a group, all sophomores in a group, all juniors, all seniors, etc. So we want them to be similar on a similar variable. Then I need to talk about how I'm going to do the assignment. For each block pair, in other words, after I've blocked, I would flip a coin to assign the fish food. If the coin shows head, then the tank with the smaller number would receive the new fish food, and the tank with the larger number would receive the older fish food. Didn't have to do it that way, but I need to basically 4 different scenarios. I'm going to need to do it for block A, block B, block C, block D. I'm choosing to flip a coin, and that's the way I went about it. I could have put the 2 numbers in a hat and drawn. That would have been fine as well. So if the coin shows tails, then I would assign the older fish food to the smaller number in the block and the new fish food to the larger number. After an appropriate time, I would compare the average weight gain of the salmon in the block pairs to determine which food enhanced growth the most. So always we have to come back to comparing what we're measuring. So in this case, our response variable was weight gain, so we need to come back and actually compare the weight gain. Our treatments were the food was one of the treatments. The other treatment, of course, were the blocks in this design. This is a fairly complex problem because we had to take in, we had a weird blocking design because basically we had a ton of blocks because we had a ton of different heat situations that we needed to address. So hopefully that will help with this. And please study this as you may see something again.